Hello seniors, I hope you're doing fine. Today we're going to continue with electronic assignment number 12, Pascal's triangle and the binomial expansion. And if you remember from the last tutorial video and also from the last live session we had, we've covered the theoretical part of the Pascal's triangle and the binomial expansion. We've seen what the Pascal triangle is about. And then we've seen this concept of combinations, which are the different coefficients we find in the Pascal's triangle. And then we've seen how to calculate the combinations using a formula which involves factorial. And we've also seen some properties that we find in the Pascal's triangle, which allows us to easily expand any type of binomial to any power, right? To a power of n, where n could be 1, 2, 3, 7, 8, whatever, okay? So today we're going to practice by applying all of these concepts into problems that usually appear in the IB exams and where students usually struggle because they do not understand these concepts clearly. So let's see and try to really understand this, because you'll see that if you understand these concepts, the problems are not that hard as they seem. So we're going to start with an easy exercise. It says that use the binomial theorem to expand x plus 3 to the power of 5. Write your answer in simplest form. So I'm going to show you two ways: using calculator and without calculator and with calculator. Okay, so if we're not going to use calculator, in order to expand this, we should first determine what are the coefficients in front of each of the terms in the expansion by using the Pascal's triangle, or by applying the formula, which is nr and then n factorial and so on. We could also do it that way, but I think it would take us a little bit more time. So if I am asked to do the expansion of this, the first thing I need to look is the exponent. Since this is to the power of 5, I will have to build the Pascal triangle up to row number 5. Okay, so I'm going to start by doing that. I'm going to do a Pascal triangle. This is row 0, row 1, row 2, row 3, 4, and 5. Okay, then I'm going to fill with 1 the other side. Try to be organized when doing your Pascal triangle and make sure you fit all the numbers inside each of the squares in the grid paper. Okay, so let's fill in this Pascal triangle. This would be 2, this would be 3, 3, then this is 4, 6, 4, and finally we have 5, 10, 10, 5. So this is the 5th row. This is the 5th row, which we're interested in. So in order to expand, let me do that here. In order to expand x plus 3 to the power of 5, we would have to write the coefficient first. So the first coefficient is 1. I'm going to write this 1. And then remember the rule. This first term begins with the maximum exponent possible, which is x to the power of 5. And this begins with the lowest possible, so 3 to the power of 0. Okay, x to the power of 5 times 3 to the power of 0. Then plus, second coefficient is 5. I'm not sure if this is going to fit here. I'm going to take this a little bit more to this side. Plus, this is 5 times x to the power of 4 times 3 to the power of 1. The x decreases in 1, its exponent, and the 3 increases by 1. Then plus 10, which is a third coefficient, x cubed times 3 squared, plus 10 again, x squared times 3 cubed, plus 5, x to the power of 1 times 3 squared. I'm going to take this a little bit more to the left. There, plus 1 times x to the power of 0 times 3. Wait, there's a mistake here. I saw the mistake. This should be to the power of 4, and this is to the power of 5. Remember, the 3 should end up with the maximum exponent, which is 5. So once I have written this, I need to simplify the expression. So x plus 3 to the power of 5 would be equal to x to the power of 5. Remember, this is 1, so we don't have to write that. Plus 5x, no, sorry, 5 times 3 is 15. So this is 15x to the 4th. Then 3 squared is 9 times 10 would be 90, 90x cubed. 3 cubed is 27 times 10, that's 270 x squared. Then we have 3 to the power of 4, that's 81. And 81 times 5, that's 405, so plus 405x. And finally, 3 to the power of 5 is 243, so plus 243. So this is the result of the expansion, and this would be our answer, okay? I hope this is clear enough for you. So that's how we expand this first binomial. Then, if we use our calculator, in this case, it will not be easier by using a calculator, but I want to show you the process just for you to understand. If you remember from this class here, we saw the general form of expanding any binomial. Okay, so this is a plus b to the power of n, and this is the sequence that we should follow, right? It's n0, the coefficient in Pascal's triangle, times a to a maximum exponent times b to a minimum exponent, and then this decreases and the b increases, right? That's the general pattern we should follow. So if we want to apply this formula, I'm going to bring this down. If I want to apply this formula into this problem, it'll work this way. We would write x plus 3 to the power of 5 equals, and the first term would be 5, 0, remember the exponent is the value of n, of a, which is x to the power of 5, times b, which is 3 in this case, to the power of 0, plus 5, 1, a, 4 times 3, 1, plus 5, 2, so we're following the sequence, right? Sorry, I wrote here, it should say x. X cubed times 3 squared plus, and we keep on doing this until we reach 5, 5. This would be x squared, 3 cubed, plus 5, 4, x 3, x1, 3 to the power of 4, and finally 5, 5, x0, 3 to the 5th. Okay, so to calculate these values, we're going to use the calculator. Okay, so if you pay attention to the calculator, let me record this for a second. So there you go. Now you can see the calculator, right? So we go to menu 1, the main menu, and you remember, let me erase this. Remember the steps: option, F6, and then prob, and you click on NCR, okay? So the first value we want to know is 5, 0, which is the first coefficient. If we plug in 5, 0, we get 1. So I'm going to write those values in the... let me calculate all of them, and then we're going to go back. So that's the first one. Then for the second one, we want, this to be 5, 1, right? This gives us 5. And if we keep on doing this, 5, 2, we would get 10. Then 5, 3, we would get 10 again. Then 5, 4, we would get 5. And finally, 5, and we should get 1. You see that the numbers repeat once we reach... let me go up. The pattern repeats after this 10, right? Then we have 10, then it goes decreasing, 5, 1. So if you calculate to the first half of the term, you could just repeat those values afterwards, okay? That's just to buy some time. So if we go back to the electronic assignment, let me write the coefficients here. So x plus 3 to the power of 5 would be 5, 0, the coefficient was 1, so this is x to the power of 5. 3 to the power of 0 is just 1, so I can write 1 here. Plus 5, 1, this gave us a coefficient of 5, x to the power of 4 times 3. Then this 5, 2 gave us a coefficient of 10. Remember, these are the coefficients of the Pascal triangle. Times 9, plus this also gave us 10. X squared times 27, plus this gave us 5 again. So 5 x 3 to the power of 4, we said that was 81. And finally 5, 5 gave us a coefficient of 1. X to the power of 0 is just 1, so we can write times 1, times 3 to the power of 5, which is 243. Finally, if we organize these terms, we would get x to the power of 5 plus 15 x to the 4th plus 90x cubed plus 270 x squared plus 405 x plus 243. And this should be the same answer we got without using the calculator. And if you check that, you will see that the result is the same. Okay, so I normally prefer to do without using the calculator, but there are some times in which, for example, you're asked, and this is very common in an IB exam, where you're asked to find, for example, x plus 3 to the power of 20, right? And it takes a lot of time to build 20 rows in the Pascal's triangle. You could if you can, but if you want, sorry. But it will take a lot of time, so I don't think it's convenient with respect to time, right? It's easier to just plug in the values in the calculator and calculate the first 10 coefficients, and then you know that the other coefficients repeat each other, right? So you're gonna buy some time there. Okay, so I hope that was clear. Let's see example 26 now. It says, use the binomial theorem to expand this expression. So this is the same case. We're just adding a little complexity in the second term and also in the first term, but the process is exactly the same. So I'm gonna do this without calculator, just to practice a little bit, without GDC. So once again, I'm gonna build the Pascal triangle up to row 3, because that's what we're asked to find. So, sorry, up to row 3. So I'm gonna bring this row 3 up to there. So to avoid wasting time, I'm just copying this here. So we know that row 3 is this one, right? Third row. So to expand this, we're gonna write as follows. 2x minus 5y cubed equals the coefficient 1 times the first term, which in this case is 2x to the power of 3, right? Maximum exponent, times the second term, which, pay attention here, we have a negative in front, so the term is actually negative 5y to the power of 0, okay? Then plus, second coefficient is 3. 3 times 2x to the power of 2 squared times negative 5y to the power of 1, right? Then plus this coefficient, 3 times 2x to the power of 1 times negative 5y squared. And finally, plus this coefficient over here, 1 times 2x to the power of 0 times negative 5y cubed. Finally, we need to simplify this expression, so we're going to write 2x minus 5y cubed equals. This becomes 1, so we don't need to pay attention to that. I'm going to leave it as 1 here. So this would be 2 cubed, that's 8x cubed. Then plus, here we have 4, 2 squared is 4. 4 times 3, that's 12, and 12 times negative 5, that's negative 60, right? 12 times 5, yes. So negative 60 x squared y, okay? Don't forget the the variables. Then plus, here we have -5 squared, that gives us 25. 25 times 2, that's 50. 50 times 3, that's 150. Positive 150. Xy squared, right? And finally, the last term would be would be actually negative minus 5 cubed, that's 125, times 2, that gives us 250. So minus 250 this whole term, this whole term is 0, so this is not 250. This whole term is 1, sorry. So this becomes negative 125 y cubed. There you go. So if you pay attention at something, you will realize that you don't even have to pay attention at the signs of the. If you remember from when you did this in 7th grade, maybe, if we had a negative here, let me show you the different color. If you had a negative here, then the rule was that we had to vary the signs. So this is, let me change this. This is actually, this should be negative because we have a negative in front. So I'm going to put negative here. The rule that was that if this was negative, then we had to change signs. This was positive, then negative, positive, then negative. But with this formula, we don't even have to remember the rule. Why? Because the development of the problem would already put the corresponding signs in each case, right? We didn't worry about the sign, but the term, when elevated to a specific exponent, specifically to an odd exponent, made it negative, right? And when we had that same term to an even power, that made it positive, okay? So you don't even need to remember to apply the rule. The development of the problem itself already determines the signs of each of the terms, okay? So I hope this is clear enough for you people. So this is the expansion of 2x minus 5y cubed. Okay, then we're gonna see this case. We're getting into more difficult problems each time. In this case, the problem is that we have an x in the denominator, and also this x is already squared. So you will see that the process is exactly the same, but you need to pay attention in order to not get confused by this. Okay, so once again, this is cubed, right? So we're gonna solve this once again without using GDC, just to practice a little bit. And since we're asked to the cube power, I'm gonna bring this back. This Pascal's triangle, I'm gonna put it here. Oh, what happened there? There you go. So if we want to expand this, you'll see that we'll follow exactly the same rule. We need to identify that this is our A, right? And this is our B term, okay? So remember that because you're always going to be applying that same rule. So if we go to the expansion, let's write x squared plus 2 over x cubed. So the first term has this coefficient of the Pascal's triangle, so 1 times the value of a, which is x squared. I always recommend using parentheses to avoid confusion. This should be to the power of 3 again, which is the maximum exponent, times b, which is 2 over x, to the power of 0. Okay? Then plus second coefficient, 3 times the value of a, which is x squared. Its exponent now decreases, so this would be squared outside. And the value of b is 2 over x to the power of 1. This goes increasing. So do not get confused with this squared value over here. That squared value is always the same because the term has already the squared value. Okay, so we're only decreasing the external exponent we have there. Okay, plus this coefficient 3 times a, which is x squared always, to the power of 1, times b, which is 2 over x squared. And finally, plus this coefficient over here, 1 times a, which is x squared to the power of 0, times 2 over x cubed. Once we've done that, we need to expand this, or simplify the terms, actually. So we're going to simplify the terms here. This equals this terms becomes 1, so we don't care about that. So this would be x squared cubed would be x to the power of 6, right? Plus then 2 times 3, that's 6. 6x to the power of 4 over, there's an x appearing here down, over x. So we would need to simplify this later on. Plus, then we have 2 squared is 4. 4 times 3, that's 12. So 12 x squared on top, and x squared also at the bottom, x squared. So we would simplify that as well. Finally, the last term would be, this becomes 1. So it's only 2 cubed, that's 8, over x cubed. Okay, so if we simplify the terms, you see that this x can be simplified with this 4 and become a 3 here. This goes directly with this, and then that's it. So finally, the answer would be, let me rewrite this here. The answer would be x to the power of 6 plus 6x cubed plus 12 plus 8 over 3. So over x cubed. So this is the expansion. You see that, and this is also very typical from the IB. What will be the independent term in this expansion? Remember, the independent term is a term that does not have any variable, not x, not y, or any other variable that we can have in a problem. So in this case, the independent term is this 12 over here. You're generally asked in an IB exam to find the independent term, so you should know that that's the term where all of the variables simplify each other, okay? We're going to be seeing that in the future classes. Okay, so let's do one last exercise before we're going to leave this for the following class because it has some other new concepts and I don't want to make this class too long. So we're going to do this one to finish with this. You see that we have almost the same situation as the previous one. The only difference is that instead of having an x down here, we're having a y. But the process is exactly the same. So once again, this is cubed. So we're going to be using the same Pascal triangle we used in the last two exercises. So we build our Pascal triangle and then we solve. So we're going to write 4x squared plus 1 over 2y cubed equals first coefficient 1 times a is all of this, right? So in parentheses, we put a to the maximum exponent, which is 3, times b, which is all of this, to the power of 0. Okay? Then we do the same thing. Plus, second coefficient is 3 times a to the power of 2 times b to the power of 1. Then plus 3 times 4x squared to the power of 1 times b 1 over 2y to the power of 2. Finally, the last term is plus 1 times 4x squared to the power of 0 times 1 over 2y cubed. Okay. So now we organize terms. We know that this term over here is 1 because it's to the power of 0. This term over here is also 1 because it's to the power of 0. So then, if I copy this, we would get 4 cubed. 4 cubed, that's 64. 64x squared to the power of 3, that's x to the power of 6. Plus 3 times 4 squared. 4 squared is 16. 16 times 3, that's 16 times 3, that's 48. And 48 divided by 2 is 24. So plus 24, the x is to the power of 4, x to the power of 4, and the y is to the power of 1. So divided by y. Then next term, this is 3 times 4, that's 12. 12 divided by 4, because it's 2 squared. So 3 times 4 divided by 4, that gives us 3. Plus 3 x squared over y squared, right? Over y squared. And finally, the last term would be 2 cubed, that's 8. So 1 over 8 y cubed. And this would be the result for this expansion. This over here. Okay. So that would be it for today's class, seniors. I hope this is clear enough. If not, let me know and we can review this content in our next live session, or we could just discuss it through Google Classroom or WhatsApp, or however it's more convenient for you. So I hope you enjoy this and see you next time.